Well, in this video, let's put it all together. What we've learned thus far. We're going to talk about amplitudes, periods, and displacements all at the same time. Two objectives here. Given a function of the form y equals a times the sine of bx plus c, or y equals a times the cosine of bx plus c, we want to find the amplitude, the period, and the displacement, and we want to sketch the graph, and we're going to look about sketching one period. Our second objective, write an equation for a function with the given amplitude, period, and displacement. All right, we know a lot coming into this. Let's go over it. These graphs have amplitudes equal to the absolute value of A, are inverted about the center line if A is negative, have periods equal to 2 pi over B, have displacements equal to the opposite of C over B, and have 5 key points within each period. Those key points are zeros, maximums, and minimums, and the distance between these key points is equal to the period divided by 4. All right, let's do some examples and see how this works. I'll move my sheet up. I think I'm in a good place. Okay, our first objective we're going to do here in example 4. Sketch the graph of y equals 2 times the sine of 3x minus pi. Okay, amplitude is equal to the absolute value of A, which in this case is the absolute value of 2. The amplitude is 2. So I'm going to go onto my graph just while I'm sitting here, and I'll go up and down, because this is going to go from 2 to negative 2. Okay? The period. Okay, the period is equal to 2 pi over b. Okay, so that's 2 pi. B is 3. The period is 2 pi over 3. So one full cycle of this function will take place within 2 pi over 3 units. Okay, the period divided by 4 gives us the distance between the key points. The period is 2 pi over 3 divided by 4, and that will be pi over 6 if we do that math. So the distance between our key points will be pi over 6 units, and our displacement, I'll abbreviate that displ, is equal to the opposite of C over B. Be careful with this sign. The opposite, I'll use parentheses because the C here is negative pi, and we don't want to lose that negative. Okay, and of course the B is 3. People will lose this negative. They'll think this negative applies to this. It does not. This is the opposite of whatever C is over whatever B is. C is negative pi, so it's the opposite of negative pi over 3, which turns out to be exactly pi over 3, and it's positive. Okay? This displacement is going to be our starting point. Okay, we're going to move pi over 3 to the right to start to graph one period of this function. Okay, so we're going to start at pi over 3. Let's create our table here. And if we put pi over 3 into this function, it's the sine function, we come out with 0. And then our distance between our key points is pi over 6. So I'll add pi over 6. And pi over 3 plus pi over 6 is pi over 2. And then I'll add pi over 6 again. And then it'll give me 2 pi over 3. And then I'll add pi over 6 again. And that will give me 5 pi over 6. And then I'll add pi over 6 again, and that will give me pi. So I'm going to go from pi over 3 to pi. Well, pi minus pi over 3 is 2 pi over 3. That's the period. And if we put these numbers in, we're going to get 2, 0, negative 2, and 0, because that's our sine function. 0 up 2 goes up. Because it's positive here. So starting at 0, go up to 2, come back to 0, go down to negative 2, go back to 0. Okay, since we're using pi over 6 as our distance between key points, let's label this going between pi over 6. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. So pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6 is pi over 2, 4 pi over 6 is 2 pi over 3, 5 pi over 6, and then 6 pi over 6 is pi. Okay, start to the right, okay, positive pi over 3. That's where our sine curve is going to start. It was displaced. This is the displacement distance. This is a positive pi over 3 displacement. Okay? It's a positive pi over 3 displacement because that's what we found this right from here. And then we just graph. There's the 2. I think maybe a little bit too high. Okay, there goes the 0. Here it comes down. Whoops, I'm way too high and too low. Look at me. Okay, there's the negative, and then that goes back to pi. And I was a little high here, so let's kind of shrink that one down. And there you have it. There's one period of this function, 2 times the sine of 3x minus pi. Okay, now, we displaced it from here. So in this case, this is the period from here to here. And again, pi minus pi over 3 is equal to 2 pi over 3, which is the period which we got right here. Amplitude of 2, so we got 2 and negative 2, etc., etc. So there's what we're looking for. Let's take a look at this in Desmos, and we're going to check off these points right here. Okay, I'll get the calculator, get Desmos out, get on the screen, I hope. Okay, go into here. The function was y is equal to, and we're talking about this 2, so 2 times the sine, so go to functions, press sine, of 3x minus pi. There's the pi key at the bottom there. I'll close the parentheses, and here it is. Okay, something's not working quite right. 2 times, I made a mistake, 3x, y equals 2 times 3x minus pi. Where did I goof up? Because this goes right through 0. Oh, I know what I goofed up. This is the displacement. It turns out it goes through 0. Turns out the displacement, the graph would go right back through 0 in this case. So it got displaced because of the way it's done. But here is the period that we did. Okay, this is the pi over 3 is a little more than 1. So that's our first point. There's pi over 3 comma 0, which we came up with. Here is pi over 2 comma 2. Here is 2 pi over 3 comma 0. Here is 5 pi over 6 comma negative 2, and these are matching on my table. And then there's the period pi over, the point pi comma 0. So from here to here is the one period after it's been displaced. It just so happens, and I did not know this, obviously, I kind of got caught unprepared, that when we go back, because of this displacement, we actually go right back and we hit the origin. But again, you'll notice it was a sine with a positive, so we started out on the x-axis and we went up. So that's going to be the period of relevance right here. Okay, so there we have that one. Again, if we were to go back on this graph, we would see that this goes right back and goes back through the origin. Okay, but we're looking for one period, and we want to make it look like the sine function. In this case, the sine function is not inverted because it's a positive a. Okay, let's take a look at another example, and then we'll take a look at objective number 2. Alrighty, let me get it straightened out. Let me get my, my notes together, because I have to have the notes with me. I can't do this on the fly, otherwise I make too many mistakes. Okay, sketch the graph of y equals -8 times the cosine of 2x plus pi over 6. So we're going to notice this is the graph of the cosine. Cosine normally starts high and comes down, but because it's a negative, it's going to start low and go up. And we want to see how much is going to be displaced before it starts. Okay, let's do the amplitude is equal to the absolute value of A, which is the absolute value of -8, which is 8. Okay, I'll go ahead again here, and I'll go on to my graph. And this time I'm going to call one mark above and below 8 and -8. I just changed the scale of my y-axis. Okay, the period. Oh, let's remark about the negative sign. Negative sign tells us we want to invert about the center line. So normally the cosine starts high and comes low, but because of the negative, we're going to invert. We're going to start low and go high, okay, because of the negative sign here. Okay, the period is equal to 2 pi over b. b is 2, so this is 2 pi over 2, so the period is pi. Okay, so one period or one cycle of this function is going to take place within pi units. Okay, the period over 4 is pretty easy, pi over 4. So the distance between key points is going to be pi over 4. What's the displacement? How much am I going to displace this because of this plus pi over 6 here? Well, the displacement is equal to the opposite of c over b. The opposite, well, c in this case is pi over 6. That's the numerator. b is 2. We'll do the math to this, and the displacement is going to be to the left. The negative sign means go left. Pi over 12 units. Again, this is our starting point. Okay, so we're going to start at negative pi over 12, starting point. The distance between our 5 key points is pi over 4. So I'm going to add pi over 4, and this becomes, let's see here, pi over 12 to 0 pi over 12 to 1, 2, 3 pi over 12. No, pi over 12. I think it goes to 3 pi over 12, which is, that's not correct, negative 1 pi over 12, 0 pi over 12, 1 pi over 12, 3 pi over 4, I believe. And then I'm going to add pi over 4, that's pi over 2, I hope that's correct. And then I'm going to add pi over 4, that is not, is this right? 3 pi over 12, 4, 5, this should be 7 pi over 12, I think. Well, now I've got myself caught. Just give me half a second here. Negative second pi divided by 12 plus pi divided by 4 and second pi divided by 4. That is not correct. This is going to be, I go up pi over 4, which is the same as 3 pi over 12. That's where I goofed. This is pi over 6. Okay, I'm glad I checked that. Add pi over 4, and I get to 5 pi over 12. Add pi over 4, I get to 2 pi over 3. Add pi over 4, and I get to 11 pi over 12. Okay, let's notice 11 pi over 12 minus a negative 11 pi over 12 is a solid pi. It's the same as 11 pi over 12 plus pi over 12, and that's 12 pi over 12 or pi. Sorry about the slip up there. Now we'll put these numbers into this, but I already know the answers because this one's going to give me a negative 8 because it's a negative here, and the cosine is going to start at the negative and go up. There's my 0, there's my 8, there's my 0, and there's my -8. Or you can plug these into here and do the math in radians. Okay, now let's graph it. Okay, so now I'm going to do pi over 12 units. So I'm going to do it as, I'll go every 3. So let's see, this is pi over 12, 1, 2, 3, 2 pi over 12, 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10. Woof, I made it. This is negative pi over 12. This is pi over 12. 2 pi over 12 is pi over 6. 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3. 5 pi over 12. This is 6 pi over 12, or pi over 2. 7 pi over 12, 8 pi over 12 is 2 pi over 3, 9 pi over 12 is 3 pi over 4, 10 pi over 12 is 5 pi over 6, and 11 pi over 12 cannot be simplified. Okay, so I started it here, and I counted up pi over 12s. So we start here at -8. Okay, notice this is the displacement. Okay, negative pi over 12 is the displacement. We started to the left 12, and because we have the negative here, we start going down and we go up. And we know that we go to pi over 6, we go to 0, and then 5 pi over 12 is 8, and then 2 pi over 3 is back to 0, and then 11 pi over 12 is back to -8. And this graph kind of has a longer, more stretched out look because my x-axis is counted by pi over 12s instead. But that's your cosine graph inverted from that distance. Okay, for this function. Okay, now let's look at our period. We displace back, so the period starts here and goes to here. We had to start here, and so this is the period. And the period we said was pi. Well, 11 pi over 12 minus a negative pi over 12 is indeed 12 pi over 12, which simplifies to pi. So that is our graph right there. Let's make a note of these points, and let's take a look at them in Desmos. Okay, let's go back to here. I got Desmos in front of you, I hope. I need the keyboard. There we go. Okay, let's take a look. Y is equal to -8 times the cosine of 2x plus, I'll put a fraction in there because I want to have a pi in the numerator and a 6 in the denominator. And there it is. I'm going to kind of shrink it down a little bit this direction. Okay, so here, remember the cosine, so here is, that's our, we shifted, we displaced back. Let's see if we got it right. We did. We went back pi over 12, and we started at -8. And then here we're at pi over 6, 0. Here we're at 5 pi over 12. Here we're at 2 pi over 3. Notice that these match the chart, the table of values that we made. And then there is 11 pi over 12, comma -8. And from here to there is one cycle of this cosine function. So that's what it looks like in Desmos. All right, last objective, we'll do one example. This is fairly straightforward, at least in comparison to what we just did. Okay, so objective 2, write an equation for a function with the given amplitude, period, and displacement. Okay, so our example here, write the equation for the given function with the given amplitude, period, and displacement for the given function with the given amplitude, period, and displacement respectively. The function is going to be a sine function. Amplitude 4, period 3 pi, and the displacement of negative pi over 4. Okay, so I need to write a sine function. Okay, it's going to look like this. Y equals a sine bx plus c. So I need to find a, b, and c to get this function. Okay, again, it's a sine function. That's why I wrote sine. Well, the amplitude is easy, or easier. Amplitude. Right there it is. It's 4. So the a is equal to 4, because the amplitude is very straightforward. Okay, the period. We know the period is equal to 2 pi over b, and we're told that our period is 3 pi. So 2 pi over b has to equal 3 pi, and we want to solve this for b. Okay, well, let's multiply both sides times b. 2 pi equals 3 pi times b. Let's divide both sides by 3 pi, and b is equal to 2/3. That's b. b is 2/3. Okay, and now let's do the displacement. The displacement is equal to the opposite of c over b. Notice we have to have b, so I had to do period before displacement. And our displacement is equal to the opposite of pi over 4. Okay, well, first of all, I noticed I have negatives on both sides. So I can drop the negatives by multiplying both sides by -1. And I know b is 2/3. So c over 2/3 is equal to pi over 4. Okay, this is a proportion. I'll cross multiply. So 2/3 of a pi is equal to 4 times c. I just cross multiply because it's a proportion. Divide both sides by 4. And I come up with the fact that c is equal to pi over 6. I think I have enough space still in my paper. Is everybody in here? I think I do. Okay, so what's the equation? Y is equal to a, which is 4, times the sine of b, which is 2/3, times x. This is positive c, so plus pi over 6. That's the function that will meet this criteria right here. If we want to take a look at it in Desmos, we can take a look and get a couple of the things out of this without too much difficulty. Let's cancel out of that one. Okay, so we came up with the function being y is equal to 4 times the sine, 2/3. I'll put a division symbol to get my 2/3 in there. Whoops, 2/3. I'll come over, whoops, I got to go back to there. Okay, times x plus another fraction bar, pi, put a 6 in the denominator, and then I will close the parenthesis, and here it is. Okay, so we can see here, this is the sine function. Okay, sine function. We can see, let's see, there's our starting point, and we'll notice that from one full period goes from here, which is negative pi over 4, to here, which is 11 pi over 4, to go from the 0 down and back. 11 pi over 4 minus negative pi over 4 is 12 pi over 4, and that's 3 pi. So we have the period, and we can see that here, the high is a 4, the low is a -4. Take the high minus the low, get 8 divided by 2, and that's your amplitude. And the displacement, of course, relies on a bit more. Oh, the displacement, we were told right here. I'm sorry, let me cancel these points out. Right, there's the displacement. We were told the displacement is negative pi over 4, and there it is right there. So there's our displacement. We got our amplitude, and we got our full period from here to here. Okay, there you have it. All kinds of stuff, and enough stuff to keep you occupied for some time.